Hello, everyone, and welcome.
Welcome back, everyone, for another deep dive. Today we're going to be tackling something that's, well, frankly, kind of straight out of science fiction. Brain-computer interfaces, or BCIs for short.
Yeah, we're talking about making that sci-fi dream of controlling tech with your mind a reality.
Exactly. And we're not just talking, moving a cursor with your thoughts or something, although that's obviously, like, super cool in itself, but...
Yeah, no, we're way past that. Think restoring lost senses, like, Imagine helping someone who's paralyzed regain movement.
Even giving a voice to people who are completely locked in. I mean, that's just mind-blowing.
It really is. And the research in this field is just exploding. Did you know there are over 500 research groups around the world working on BCIs right now?
Seriously, 500?
That's huge. And it just goes to show how much potential there is here.
Yeah, absolutely. So for our listeners who might be hearing about BCIs for the first time, can you give us a quick breakdown? Like, what exactly are we talking about here?
Sure. At their core, BCIs are all about tapping into the brain's electrical language. Every thought you have, every movement you make, it's all just neurons firing off electrical signals. What BCIs do is they essentially eavesdrop on these conversations happening inside your head.
Okay, so they're like listening in on the brain's chatter. But how do they go from eavesdropping to actually understanding what I want to do? Like, make a cup of coffee with a robotic arm or something.
Right, so that's where it gets really, really interesting. Imagine, well, think of it like Shazam, but for your brain.
Shazam, like the music app.
Exactly. So, you know how Shazam can identify a song just from hearing a few seconds of it? BCIs work in a similar way. They have to identify the specific brainwave patterns that mean reach for the coffee, grab the cup, and so on. That process of identifying those patterns, that's called feature extraction.
Okay, so it's like picking out the grab coffee melody from all the other neural noise going on. I'm starting to get it. So what happens once the BCI has picked out the right song, so to speak?
Then it's time to translate those brain signals, those patterns, into commands that a computer or device can understand. It's basically like translating brain language into computer code. And we call that, those are called translation algorithms.
So find the right signals, then tell the computer what those signals mean. Makes sense, but something tells me it's not always as easy as strapping on a headset and suddenly having a mind meld with my coffee maker.
Right. You're right. It's not quite that simple just yet. You see, there are actually different types of BCIs, each with its own pros and cons. Some are what we call invasive, which means they involve surgery to implant electrodes directly into the brain.
Okay, so when we talk about invasive BCIs, we're talking about like actual implants, right?
And I know the word invasive might sound a little intense, but
Yeah.
it's important to remember, like those EEG caps you often see in research labs, those are actually non-invasive BCIs. So they offer a way to kind of dip your toes into this technology without needing any surgery.
So there's like a spectrum of, we'll call it brain interfacing going on here, depending on what you're trying to do. But if invasive BCIs, the ones that involve surgery, if those are the ones getting the most accurate readings...
You're on the right track there. Invasive BCIs, they do generally get the clearest signals because they're right there, at the source of the action. But of course, there are always going to be risks with any kind of surgery. That's why researchers are constantly working on improving all types of BCIs, trying to make them less invasive and more user-friendly over time.
Okay, so we've talked about how BCIs work, but I think what really gets people excited and maybe a little nervous are the potential applications. So let's dive into that. What are BCIs actually capable of doing right now?
Well, one area where BCIs are making absolutely incredible strides is in restoring vision.
Really?
Yeah, there's actually a really amazing case, a guy named Jerry. He received an implant that allowed him to perceive shades of gray after years of blindness.
Wait, hold on. You're saying he could actually see again?
In a way, yes. It was a huge moment in the field because Jerry's case showed that even decades-old vision loss could be partially reversed. You see, the brain is amazingly adaptable, what we call plasticity. And what they did with Jerry is they implanted a device that essentially used cameras to send signals directly to his visual cortex, bypassing his damaged eyes.
So even after all those years, his brain was still able to process those signals, like it was waiting for them.
Wow, that's incredible. So if BCIs can be used for vision, what about other senses? Could you use them to restore hearing or touch? That's the million-dollar question, isn't it? And the short answer is that's exactly what researchers are working on right now. Think about it. Our senses, they all work by converting, let's say, light, sound, pressure, those external stimuli. They're converted into electrical signals that the brain can understand, right? What BCIs offer is this potential to deliver those signals directly to the brain, even if the sensory organ itself is damaged.
So it's like creating a new pathway for those senses to reach the brain. That's amazing. Okay, so we've got vision and potentially other senses. What about movement? You mentioned people with paralysis using BCIs earlier.
Yeah. And this is where things start to feel like, really futuristic.
Hmm.
I mean, we've all heard about those experiments where people can control a computer cursor with their thoughts. But researchers have taken it way beyond that. There's this amazing case, a guy named Matt Nagel. He was paralyzed from the neck down, and using a BCI, he could control a robotic arm, just with his thoughts, reaching, grasping, even picking up objects.
Wow, that must have been absolutely life-changing for him.
It was. And, Matt's case really showed the potential for BCIs to restore lost independence, giving people back that ability to interact with the world around them. And think about people who are facing even more severe paralysis, like those who are completely locked in. BCIs could be a literal lifeline for communication.
So even if someone can't move or speak, the BCI can pick up on their brain activity and allow them to communicate with the outside world.
Precisely. Giving a voice to those who have lost theirs. Allowing them to express their thoughts, their needs, their emotions. Imagine the impact that could have on someone who was previously completely isolated. It's really profound.
It really is. But let's be real for a second. I mean, as amazing as all of this sounds, there have to be challenges. What are some of the hurdles that researchers are still trying to overcome?
Oh, there are definitely still challenges. For one thing, BCIs right now, they often require a lot of training, a lot of calibration. It can be pretty time-consuming and mentally demanding, to be honest.
So no putting on a headset and instantly controlling things with your mind then.
Not just yet. But that's the dream, right? And researchers are working on it, making BCIs more intuitive, more adaptable, so it feels more like an extension of your thoughts, not this separate device you have to learn how to operate. And of course, there are the technical hurdles. I mean, we're constantly trying to improve how accurately we can decode brain signals, making implants less invasive, figuring out things like battery life, how to make these devices last a long time inside the body, biocompatibility and all that. It's a huge area of research.
It's like we're on the verge of this whole technological revolution, but like with every revolution, there's always, a whole new set of questions we got to ask ourselves, right? So thinking about BCIs, what are the ethical things we should be thinking about? I mean, this tech feels so personal.
Yeah, it really does get into some deep territory, doesn't it? And you're right, it's not just about what BCIs can do, it's about what they should do. And that's a conversation that goes way beyond just scientists and engineers. We all need to be a part of it.
For sure. So, like, what are some of the big ethical questions people are, grappling with right now?
I think privacy is a huge one. I mean, if you've got a device that can read your brain signals, how do we make sure it doesn't, like, cross the line, accessing your thoughts, your memories, your innermost self?
Oh, yeah, that's kind of scary, right?
Yeah, it's a big deal. Figuring out how to protect mental privacy in a world with BCIs, that's got to be a top priority.
It's like we almost need a whole new definition of privacy in the age of BCIs. You know what I mean?
Totally.
Mhm.
And it goes even deeper than that. What about human enhancement? Like we've talked about restoring lost functions, but what if we start using BCIs to enhance our abilities beyond what's considered normal?
Right, like where do we draw the line?
Exactly. And that's a question that, philosophers have been debating for centuries, but BCIs, they bring it into the here and now. If we can use technology to make ourselves smarter, stronger, faster, should we? And what about the people who don't have access to that kind of enhancement? Does it create a whole new kind of inequality? These are really complex issues.
Definitely. It feels like we're not just entering a new technological frontier, but a whole new ethical frontier at the same time. So is anyone actually working on like setting some guidelines for all of this, for how BCIs are developed and used?
Oh, absolutely. There are a lot of people who are really aware of these ethical questions, and there's a growing movement within the BCI community to address them head on. Like right now, different groups are working on developing ethical guidelines for research, for development, for everything, prioritizing things like safety, informed consent, equitable access, making sure this technology benefits everyone, not just a select few.
That's good to hear. It sounds like there's a real awareness of just how big of an impact BCIs could have, both good and bad. So with all that in mind, where do you see this going? What does the future hold for BCIs?
Well, if I could predict the future, I'd be, writing this from my own private island somewhere.
Ah, right.
But seriously, the research is moving so fast that it's really hard to say for sure where we'll be in 5–10 years.
Mm.
But what I can say is that this is a truly revolutionary technology. We're at the very beginning of something huge.
It's exciting and a little bit intimidating, too.
Exactly. But that's kind of how it always is with these big leaps forward, right? They challenge us to think differently, to rethink what's possible. And I truly believe that BCIs have the potential to make lives better in so many ways, whether it's restoring lost abilities,
Mm.
treating neurological disorders, maybe even unlocking new levels of human potential. It's a journey worth taking, even if we don't know exactly where it's going to lead.
Very well said. It seems the future is wired, and maybe, just maybe, we'll all be plugged in soon in ways we haven't even begun to imagine. Thanks for joining us for this incredible deep dive into the world of BCIs. It's been quite a journey.
It has.
And to all our listeners, be sure to tune in next time for another deep dive into the world of science and tech. Until then, keep those neural pathways firing.
Please subscribe to my channel.